13.8 billion years ago, everything that would ever exist burst into being from a point smaller than an atom. Or so we thought. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, wasn't launched to shatter our understanding of reality. It was built to confirm the greatest story ever told about how everything began. Instead, it's revealing galaxies that formed too fast, black holes that grew too large, and structures that organized too quickly. We're about to journey through discoveries that suggest our origin story might be completely wrong. If you're ready to question everything you thought you knew about the universe, make sure to like and subscribe because the truth is stranger than fiction. Prepare yourselves. We begin. Music. $10 billion and 30 years of planning created the most sophisticated machine ever launched into space. The James Webb Space Telescope wasn't built to surprise us. It was designed to look back through time and confirm what we already believed about the universe's birth. Scientists expected to see tiny, primitive galaxies stumbling through their first steps of formation. They anticipated finding sparse collections of early stars barely organized into recognizable structures. Instead, Webb revealed a cosmic nightmare for everything we thought we knew. Like opening what you expect to be a baby photo album and finding portraits of fully grown adults, the telescope showed us galaxies that shouldn't exist. These weren't the cosmic toddlers we expected to find in the universe's nursery. These were massive, organized, mature systems blazing with the light of billions of stars. Picture this. You're told a forest takes 100 years to grow. Then you discover trees that are fully mature after just 10 years. That's exactly what Webb discovered in space. Galaxies that should have taken billions of years to form were already there, fully developed. Just 600 million years after the Big Bang, the numbers don't just challenge our understanding, they shatter it completely. Webb's infrared eyes can pierce through cosmic dust and distance like no telescope before it. Its mirror stretches 21 feet across, gathering light that has traveled longer than any photon humans have ever captured. This gives us a time machine that reveals the universe when it was barely 3% of its current age. We expected to see cosmic infancy. We found cosmic impossibility. The telescope's discoveries have created what scientists quietly call a crisis in cosmology. Research teams around the world are scrambling to explain observations that shouldn't be possible according to our most fundamental theories. The very foundation of how we understand the universe's beginning is cracking under the weight of evidence. Every image Webb transmits back to Earth forces us to confront an uncomfortable truth. The story we've told about cosmic evolution, the narrative that won Nobel Prizes and filled textbooks, might be fundamentally wrong. We built this telescope to write the final chapter of cosmic origins. Instead, it's revealing that we might not even have the first page right. Webb was supposed to be our ultimate validator, the instrument that would put any lingering doubts about the Big Bang to rest forever. It has become our ultimate challenger, showing us a universe that refuses to follow the rules we've spent decades establishing. But this is just the beginning of what the telescope has revealed. The galaxies themselves tell an even more impossible story. 6 red dots appeared in Webb's deep field images like cosmic ghosts haunting the early universe. At first glance, these tiny specks seemed unremarkable among the thousands of galaxies scattered across the telescope's field of view. Then astronomers calculated their distances and ages, and the impossible became undeniable. These 6 objects existed just 500 to 700 million years after the Big Bang when the universe was still a cosmic infant. Here's what makes these discoveries so shocking. According to every model of galaxy formation we've developed, these structures simply cannot exist at that time in cosmic history. It's like finding a skyscraper in a world where only mud huts should be possible. The universe at this early stage should have been too hot, too chaotic, and too lacking in the heavy elements needed for complex star formation. Each of these 6 galaxies blazes with the combined light of billions of stars. To put this in perspective, imagine trying to build a city in 1 year using only primitive tools and raw materials. That's essentially what these galaxies accomplished on a cosmic scale. They organized billions of stars into massive structured systems in a time frame that our best theories say should be impossible. The research team led by astronomers from Swinburne University published their findings in Nature and immediately sparked controversy throughout the scientific community. These aren't just slightly unexpected discoveries. They represent a fundamental challenge to our understanding of how matter behaves in the early universe. The galaxies appear so mature and organized that they seem to mock our carefully constructed timeline of cosmic evolution. Think of galaxy formation like building a house. First, you need a foundation of dark matter to provide the basic structure. Then, you need gas to cool down enough to start forming stars. Finally, those stars need time to live, die, and spread heavy elements that enable more complex star formation. This process should take billions of years to create the massive mature galaxies Webb has discovered. The 6 objects Webb found skip most of these steps entirely. They appear fully formed when the universe should barely have had time to cool down from its initial fireball. It's as if someone fast-forwarded through the first few billion years of cosmic evolution, compressing eons of slow development into a cosmic instant. But the mystery deepens when you examine exactly how massive these impossible galaxies really are. The numbers reveal something that challenges the very foundations of physics itself. One of Webb's discovered galaxies weighs more than 100 billion times the mass of our Sun. To understand how staggering this number is, consider that our own Milky Way galaxy contains roughly 60 billion solar masses of stars, and it has had over 13 billion years to accumulate this material. These early universe giants achieved even greater mass in a fraction of that time. The Milky Way is like a massive oak tree that has grown slowly over centuries, developing deep roots and a complex structure of branches. These early galaxies are like finding fully grown redwoods in a garden that was planted last week. The comparison reveals just how impossible these observations should be according to our current understanding of cosmic evolution. Mike Boylan-Colchin from the University of Texas calculated the implications of these massive early galaxies and reached a disturbing conclusion. If these measurements are correct, we are entering completely uncharted territory in cosmology. The galaxies are so massive that they would require fundamental changes to either our understanding of galaxy formation or our understanding of the universe itself. Consider the scale of this problem. The most massive of these early galaxies contains more stellar material than galaxies that have had billions of additional years to grow and evolve. It's like discovering that a 3-year-old child weighs more than a full-grown adult. The timeline simply doesn't work with any known process of stellar and galactic development. These galaxies exist at a time when the universe was only 3% of its current age. Imagine compressing your entire adult life into just 1 year and trying to accomplish everything you've learned, built, and created in that impossibly short time frame. That's essentially what these galaxies achieved on a cosmic scale. The mass measurements come from analyzing the galaxy's light output and stellar populations. Brighter galaxies generally contain more stars, and more stars mean more mass. But these early universe objects shine so brilliantly that they suggest stellar populations that shouldn't have had time to form, let alone organize into the complex structures we observe. Current models of galaxy formation predict that building such massive systems should require at least 2 billion years under ideal conditions. These galaxies accomplished the same feat in less than 700 million years, and they did it in the hostile environment of the early universe when conditions for star formation were far more challenging than today.